Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem. First, palindromic string in an array. We're given a list of words and the problem is pretty simple. We just want to return the first one that is a palindrome. A palindrome is a string that reads the same in reverse order as it does in the normal order. So if you actually look at race car and you were to look at this in reverse order, you'd see R, A, C, E, C, A, R, and it is like the exact same. So the algorithm is going to be pretty simple. We just start at the beginning of this list, check if this is a palindrome. If it's not, go to the next string, check if it's a palindrome. If it's not, keep going to the next string until either we find a palindrome, and I think the first one in this case is actually this one, A, D, A, then we would return it. If we do not find a palindrome by the time we reach the end of the list, we will return an empty string as the default value. So there's really no faster way we can solve this problem other than that. In terms of the time complexity, let's say n is the number of strings that we have in the input, and let's say m is the max size or even the average size of a string. This would be the overall time complexity in that case. Now there's two ways we can solve this problem actually. One of them is slightly more efficient than the other, and I'll ask you which one you think is slightly more efficient. Given a string like ADA, we could just create the reversed version of that string. We can use a built-in method to do that, or we can do it ourselves. So we would create the reversal. It would also be ADA. Then we compare these two. If they're equal, we return one of them, because if they're equal, they're going to be the same, of course. If they're not equal, then we would continue. So that's one solution, just reversing the string. And the other solution would be to have two pointers, because if the strings are the same in forward as they are backwards, then basically the first half of the characters should be the same as the second half of the characters as well. So what we can do is have two pointers, a left pointer and a right pointer. Check if the two characters are equal. If they are, then we continue to look at the next characters. We would shift the left pointer to the right and shift the right pointer to the left. And what point would we stop? Probably after the pointers have met each other or crossed each other. So in an odd length string, they're going to meet right in the middle. If we had a even length string, the left pointer would be here, right would be here, and then they would cross each other. So at that point, we would know that they are palindromes. But if we ever find even a single character, suppose this character was X, and they are not equal at these positions, then we know it's not a palindrome immediately. Okay, so two solutions, one with two pointers, and the other one was taking the string and making a reversed copy of it. Which one do you think is more efficient? Well, I kind of just told you. If we have to create a copy of a string, we need extra memory. That memory would be big O of M. Let's say it's the max size of a string in here. Not only that, but to create a copy of a string, we have to iterate over the entire string. And then to compare two strings, we also have to iterate over both of them. Whereas with this two-pointer method, we only have to iterate over the string once. We don't create any extra copies. We don't need any extra memory. So I'm going to prefer the two-pointer approach. Okay, now let's code it up. Given how simple even the reverse solution is, I might as well code it up for you. So let's just iterate over every word in the inputs in Word. Let's check. Is W equal to the reversed version of it? And in Python, it's pretty easy to get the reversal. We just go like this. It basically means we want the entire string and we want it in reverse order. That's what the -1 means after the double colon. If they are, then we found a palindrome. Go ahead and return it. Otherwise, continue. If we never find a palindrome, just return an empty string here. So let's run this. As you can see, it works and it is pretty efficient. Let's see if the memory actually improves at all with a two-pointer solution, because sometimes Leetcode is kind of random with this stuff. Now what I'm going to do instead is, before we do this, let's get a couple pointers. Left and right are going to be initialized to the endpoints of the string. So at 0 and at the length of the current string, -1. And while, the way I'm going to code it up is a little bit shorthand, but there are many ways to do this, so you can do what you prefer. I'm going to check, is the character equal? Is left equal to the character at right? If it is, great. What we want to do is set left and right to L+1 and R-1 respectively. But at some point, there might be a crossing. These pointers might meet each other or they might cross. We could do this in multiple ways. We could have an if statement outside of here and then also end the loop, like add a condition here so that we don't continue looping. But an easy way is just to here, add an if statement. If left is greater than or equal to right, the pointers are equal or they crossed each other, then we know at this point it is certainly a palindrome. Let's return the string. If it's not though, we would increment, or maybe we get to a point where the characters aren't equal. At that point, we just stop considering if it's a palindrome and try the next string. This is the entire code. Let's run it to make sure that it works. As you can see on the left, yes, it does. I think the time complexity is pretty random. We could try rerunning it, but it does look like the memory improved very slightly, like 0.1 megabytes or something. If you're preparing for coding interviews, check out leetcode.io. Thanks for watching, and I'll see you soon.